Before we start the show, a quick promo swap. I want to tell you about a show I've been listening to called Science Versus. It's a science podcast that really knows its stuff. If you like Data Skeptic, there's a good chance you'll also be interested in what they do. As they say, when it comes to controversial topics, there are a lot of opinions, angry uncles, and Facebook posts, but then there's science. Science Versus is the show that finds out what's fact, what's not, and what's somewhere in between, and answers questions like, is fracking that bad? Does the G-spot exist? Is hypnosis real? Does gun control work? Hosted by Wendy Zuckerman and produced by Gimlet Media, Science Versus takes facts seriously, but not itself. So win the next argument with your angry uncle. Listen to Science Versus for free wherever you get your podcasts. That's Science VS. The new season has just launched, and there's 2 great new episodes you can start with.
Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini-episodes on topics in data science, machine learning, statistics, and artificial intelligence.
All right, Linda, before we get into the Perceptron, I thought maybe we'd play a little game and see if you can behave like a Perceptron, okay?
Kyle's handed me a map of the U.S.
Not the whole U.S.
Technically North America.
Well, I left out Alaska and Hawaii, basically, of the continental U.S., all right?
Mm-hmm.
I have classified all the cities in the United States into one of 2 categories. So let's just call it in-group and not in the group. And what I want to do is give you some examples and see if you can learn the rule for what makes a city in the group or not, all right?
I don't understand. What are the categories?
Well, I haven't told you the category yet. I'm just going to say that there is a labeling. Like I'm putting a bunch of cities in one group and other cities not in the group.
Maybe capitals and not capitals.
Well, that's an interesting idea, all right? So it's a binary thing. I'm going to tell you one by one, and then you can update your rule. So Las Vegas is in my category.
Okay.
Carson City is the capital of Nevada. So my example contradicted your original theory, right?
I'm glad you told me. I did not know what the capital was.
Yeah, I cheated because I've never heard of Carson City before. So what do you do now that I've given you an example that contradicts your theory?
Maybe it's by population.
Population above a certain level?
Yeah.
Okay, that's an interesting theory. So next I'm going to go with Ames, Iowa. Have you heard of Ames, Iowa?
I've never heard of it.
Ames, Iowa boasts a population of 61,000, and it is in my category. So what do you do now?
Has vowels.
Well, that's going to be all the cities, I think. Jacksonville, Florida is not in my category.
So tell me, what is it?
What if I tell you this? My categories are geometrically based.
Does it form a star?
No, in fact, it's linearly separable.
What does that mean?
Well, good question. That means I've drawn a line through my data, where data is the latitude, longitude points of the cities, and there's a clean separation. So if, for example, I wanted to make the categories about cities you and I have visited, I couldn't make that linearly separable.
Why?
We've been to, what are some of the cities we've been to?
Raleigh, San Francisco, Seattle.
Yep, we've been to all those places. We haven't been to Cheyenne, Wyoming, have we?
Yeah, no.
If you think of the first 3 cities you mentioned, they kind of make a triangle, as any 3 points do. And if you wanted to draw a line that separated Wyoming from those cities, so as long as I haven't made a very slight error, Cheyenne is in the middle of that triangle. So if you can picture those 4 points, it would be impossible to draw a straight line that puts the cities we have been to on one side and the cities we haven't been to on the other side.
Like visually on one side?
That's exactly right.
Can't you just put the cities on a list?
Well, then they're no longer on the map. You're essentially what you proposed. You've invented an idea called support vector machine. We're going to have to leave that for another day. So we're talking about the Perceptron today. I have drawn a line across the country. Where do you think the line would be based on the data points I've given you so far?
So you said Vegas was in your data set.
Yep.
Okay, maybe the line is north of LA and south of LA.
Okay. Well, now I will tell you that Houston, Texas is out.
That fits my theory.
Would you like to change your theory?
No.
Why not?
I thought I was right.
You got confirmatory evidence of one data point.
Right.
So you're actually behaving like a perceptron, and that's good. Perceptrons don't update unless they make a prediction different from the output. Now, that's not true of all learning approaches. There could be a good reason where, like, you want to reinforce your theory because you have additional confirmatory evidence. Perceptron doesn't do that. Okay, so I'm going to give you another city.
Oh, no.
That breaks your theory, huh?
I don't know what's wrong.
I will come up with a new theory.
Maybe instead of a horizontal line across the U.S., it's a north and south line.
Okay, interesting theory. Where would you place the north and south line?
Just west of Houston.
Well, what if I told you that Chicago is in?
I don't know.
The line I drew stretches from Los Angeles to Chicago and includes those cities. Everything north of that line was in, everything south was out. Now, that's what we call a linear discriminator.
Because you drew a line in anything north and south.
Yeah, so it only takes a line to make the separation. And technically, I guess it's a geodesic, but either way, it's just a single line that defines my groups.
What if you're on the line?
Well, then you would have to define a rule of how people on the line get included or not included. And in my case, I'm saying if you're on the line, you're in the group, which is actually pretty consistent with perceptrons. So what perceptrons do, there's a couple of properties that are unique and interesting about perceptrons. First of all,
what are they?
It is a very early form of machine learning. It was actually an early attempt to create computer vision. That's why it was called the perceptron.
Vision like seeing?
Yeah. They actually rigged up a whole network of cameras, and they used the intensity of the light going into the image as an input.
Oh.
Yeah, it was very ambitious. And from a theoretical perspective, we now know that it was a little bit weak because perceptrons have some definite limits. They can't learn certain types of things. At least single-layer perceptrons cannot. However, if you have multi-layer perceptrons, as we'll talk about in future episodes, you can actually learn some very powerful things. But just the single one, the atomic unit, if you will, here's how it works. It's a linear discriminator. So it takes in a bunch of inputs. In our game, those inputs are latitude and longitude. But in, let's say, image recognition, they could be all the intensities of the pixels of an image, or they could be, all the features or something of a problem you're working on. You have weights attached to all the inputs and a bias, and then you sum up the weights times the inputs, and you get a number. If that result is greater than 0, you say it must be in the group. If it's not greater than 0, you assume it's out of the group. If you get it right, let's say if your weights are very good and you're able to do what we call discrimination, which is just picking which category it goes into very well, then you're done. But as soon as you encounter a problem, an example use case that doesn't fit, then you want to update your weights. And you move them kind of in the opposite direction of that example, so to speak, in order that the weights you have afterwards would have predicted it correctly. In fact, every time I gave you a point to the contrary, you updated your hypothesis. And that's another feature of perceptrons. You update every single time you get an error. That's different from other machine learning algorithms where you might go through all of the data and then try and do your update. So this is a feature of perceptron that makes it slightly unique. So actually, perceptrons are a terrible choice if your problem is not linearly separable. But if it happens to be, or if you can transform it in that way, then these are a nice algorithm that many people use.
Let's take a quick break from the show this week to discuss our sponsor, Periscope Data. In particular, I wanted to tell you guys about one of my favorite features of Periscope Data, SQL Alerts. SQL Alerts allow you to write a query that checks your data, and if something seems off, automatically send you an alert. For example, maybe you want to get the count of the number of orders in the last 90 minutes. If that's below some threshold, maybe something's wrong with your site. Wouldn't you want to be the hero that discovers that before your boss does? If you're a data scientist at an agile, small or medium-sized company that likes to move fast and break things, honestly, I don't know how you can be efficient without a tool like this. And in large enterprise, well-written SQL alerts can be like the unit tests of your data. You assert your expectation about the way things should be, and Periscope Data lets you sleep at night by running all your checks on the schedule of your choosing, and only alerting you if there's a problem. Find out more at periscopedata.com/skeptics. I find myself adding more alerts every week as I find new things I want to passively monitor. Put SQL alerts to work for you at periscopedata.com/skeptics. One more time, that's periscopedata.com/skeptics.
So I had another analogy about one of the key things that makes Perceptron a little different, and it's that online component that you adjust after every input. I don't know if you remember this, but a long time ago we did a gradient descent episode. I talked about stochastic gradient descent, which is where you update every time. It's a similar idea. Do I have this right? Did you ever take tennis lessons?
Oh, yeah. I used to play tennis.
All right, tell me a little bit about your tennis lessons, specifically the coaching.
When I went to tennis camp, that was the better coach rather than my high school coach didn't really know how to play tennis. So
wait, did he tell you like things? Did she tell you things that didn't make sense given the rules? Because
the technique,
the way they score that game is mind-boggling to me. I still haven't figured that out. The points go up in weird ways, and then they keep saying love and stuff like that.
Yeah, they just made up their own way, but it's just 1 point. You could just call it 1-1, 2-1, 3-1. They could say that, but they just made it this like, I think it's from like either Australia or the English. So it's like love is 0, basically.
I thought they called it Z.
Well, you say love. You're like 15 love. 15
why is love 0? That means love has no value.
So you go from 0, then your first point's 15.
Yeah, that makes no sense.
Then your next point, I think, is the 30? I forgot.
Tell me about what made the good coach. What were the properties that made their coaching good from the tennis camp?
They actually knew technique, and they knew how to communicate and give you feedback in a way that motivated you and that you understood.
All right. So when they give you feedback, did they watch you play for an hour and then give you advice, or did they give you things as you went along?
It would be a mix, but usually as you went along.
So that is the analogy I wanted to reach out to and say that is Perceptron-like. So in a lot of machine learning approaches, it's like kind of batch learning. You'll take in the full data set and then you'll kind of optimize your model to fit it. But Perceptron is sort of a specific characteristic, even though you could adapt other algorithms to do this as well. Perceptron specifically is an online learner in that every time you see an example, you make an adjustment. It's kind of like the coach saying, all right, this time move your elbow, this time do something else.
I don't think you should call my coach a Perceptron.
Well, technically your coach is the feedback mechanism in this case.
So Perceptrons don't give feedback. They take it. So I'm supposed to be a Perceptron?
Yes. In this example, you're the Perceptron. If you do something correctly, you make no update. If you make a mistake on a single instance, then you update proportionate to that mistake.
Mm-hmm. I think a machine can probably do it better than me.
You said it here. The robot takeover is coming.
Yep. Self-driving cars. Can't wait.
The other key thing I want to point out is that the Perceptron uses that step function in its learning. So anything above 0 is the in group, true or positive, whatever. Anything below 0 is the other group in a binary classifier. And that's a little bit different from some other techniques we've talked about, such as like logistic regression, which can have a continuous curve and then it gets mapped. Perceptron has this step of pushing it to one edge or the other.
So it sees the world in black and white.
It does indeed, yes. So even though it takes in intensities, it maps them in a very binary way through the step function. And then you have to find the right weights that allow that step function to yield a good answer. And it will find the good answer if the data is linearly separable. Although then there get to be interesting questions about, does it find the optimal separation? And it doesn't necessarily, and that's again where support vector machines that I mentioned come in. But that's kind of a topic for another day.
So when you're using Perceptrons, when's the point when you're like, that's not the thing I should be using?
Well, if you know that your data is not linearly separable, then you shouldn't start with it.
But you may not know it when you start.
Yeah, so if you made that mistake, if you thought it might be and you just tried it, you would find that your Perceptrons never converge. They're always just kind of wandering about and not getting to a good answer. Good question, though. So I think the Perceptron is actually the earliest example of an artificial neural network. So even though from some mathematical points of view, it has some characteristics that aren't perfect and we have more sophisticated things that have come afterwards, its simplicity makes it easy to compute and it's an important sort of historical point and still can be at use in some problems, especially when you go into multi-layer Perceptrons. So thanks as always for joining me, Linda.
Thank you for showing me the world in black and white.
Oh, good closing. And my closing, as always, until next time, I want to remind everyone to keep thinking skeptically of and with data. Good night, Linda.
Good night. Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.